Section 6.4b is about inequalities that contain the word or. If your inequality contains the word or, you're looking to graph the union. Here's what a union is. It's the graph of a component inequality that contains the word or. The solution is the graph of either inequality, and I put in parentheses here, you want to combine the two graphs. Now this is different than 6.4a, which was the intersection. Intersection is where they cross over. The union is you just take both graphs, combine them together, and you take any portion that's shaded. Here's a component inequality, uses the word or. One thing to note is that you cannot combine this into one single inequality like you could with the and. So what I'm going to do is I'm going to take each one of these separate and solve them. We'll start by subtracting 4 from both sides. So negative 3h is less than 15. Negative 3 is connected to the h with multiplication, so you undo that with division. H and negative 5. Remember, I divided here by a negative number, and when you do that, you have to switch the sign or reverse the symbol, so don't forget to do that. Now, solving the second one, we will add 3 to both sides. 7h is greater than 21, and divide by positive 7. So h is greater than 3, and this is an or. So we're looking for the values that are greater than negative 5 or greater than 3. So we're going to create 3 graphs, just like we did with the ands. So now we're going to graph h is greater than negative 5, open circle on negative 5 because it's just greater than, and we go to the right because that's where the numbers are. They get bigger. H is greater than 3, another open circle on 3, and we go to the right. Now, with an and, you take what overlaps. And if this was an and problem, it's not, but if it was, we would take this area right here and shade that all the way, if it was an and problem. But it's not an and problem, it's an or. And the or says to take the union, which means you want to combine the two. So if I put these two together on top of each other, you end up with the negative 5 all the way to the right. Because the 3 shaded to the right is included in the negative 5 shaded to the right. And since we're combining the two, that's what we end up with. Even though this is open, it ends up being filled in the last one because you don't have to take where they overlap. You just combine the two graphs into one and take any part that's shaded. So that's your answer here, and then your graph is right there. Here's a component inequality with the word or, so we'll solve, add 7 to both sides. N is less than or equal to 2, or add 7 to both sides. Looks like n is greater than or equal to 8. So we'll do 3 graphs. The first one, n is less than or equal to 2. It's a closed circle on 2 because the sign is less than or equal to. And less than goes to the left. Greater than or equal to 8, closed circle, because 8 is also included, and we go to the right. Now, if this was an and problem, we would take where they overlap, and there would be no place to graph, because they don't overlap at all. But it's not. It's an or problem, which says take both of them, take the union of the two, or take what's in either one. So we'll take from the 2 to the left, from the 8 to the right. So we combine the two together, and this is what the graph looks like. And then my solution are all the numbers that are less than or equal to 2, but also, or they could be the numbers that are greater than or equal to 8. Here's one more practice problem with the word or, so we'll subtract the 1. 3z is less than 12, divide both sides by 3. So z is less than 4. Or z is less than or equal to 1. There's nothing that I have to solve for that. It's already done. So we'll make 3 graphs. Z is less than 4 looks like this. Open circle to the left. Z is less than or equal to 1 is a closed circle to the left. Because this is an or problem, I want the union, which means combine the two graphs. And since less than 4 includes everything that would already be less than or equal to 1, that means this one is my solution.